I'm Shehryar Sardar, and this is my Physics 2212 Lab 1 charge tape. Today we're going to go over introduction, models, experiment, code, discussion, and conclusion. The purpose of this lab is to observe interacting charged tapes to determine excess charge on the tapes, as well as to simulate the interaction of two charged particles to find at which charge does one of the tapes balance out with gravity. The two fundamental physics principles we're going to use in this lab are Coulomb's law, which tells us that the force between two charged particles is directly proportional to the charge and inversely to the sphere distance. We will use this to balance out the gravitational force to determine the amount of charge exerted. Secondly, we have electric fields, where every charged particle exhibits an electric field in all the space around them, changing whether they are positive, negative, or dipole. This will be used to determine the amount of charge exerted on the opposing charged tapes. The models we use in this lab are the electric force, electric field, and gravitational force equations. We also use the velocity and position update equations to simulate the motion of the tapes. In this results preview, you can see when the lower tape is brought up to the upper tape, it is repelled in the opposite direction of gravity, and on the right you can see at charge of 4.29 e negative 9 coulombs, it balances out with gravity. For this experiment, we had tape B, the upper tape, which is part of the system, the Earth, which is part of the surroundings, and tape A, the lower tape, which is part of the surroundings. Step 1, we charge the two tapes so they are of the same charge. Second, we tape the upper tape between two ledges by its ends to not dissipate any charge. And lastly, we held the lower tape slightly below at some distance to the upper to make it repel upwards. For this experiment, the data we collected was that the measured separation distance at floating time was 0.013 meters, the mass of the tape was 0.0001 kilograms, and the length of the tape was 0.1 meters. To calculate the results of this experiment, first we found the gravitational force on the upper tape, second we found the electric force on the lower tape, then we set them equal to each other, solved for the charge on either tape as they were the same, and it gave us approximately 4.29 times 10 to the negative 9 coulombs. To start off our code, I made our constants, mainly the value for k and the gravity vector. Then I followed with the variable for charge, which I can change to find out the exact charge of the tapes. Then I created the objects for the tapes, specifically a single particle for each to simplify the process. Then I added the initial values, specifically adding mass and velocity to tape B to simulate its possible movement. Lastly, I used the E field function to find the electric field tape A exerts on tape B. For the loop, we started with calculating the electric field acting on tape B at whatever position it is at. Then we calculate the electric and gravitational forces and sum them to find the net force. Next, we use said net force to update the velocity and positions of tape B using the velocity and position update equations. Last week, we updated the positions of the arrows for electric and gravitational force, as well as scaling the magnitudes for visibility. For the results for our code, on the left, we input the charge of 4e negative 9, where you can see the particle fluctuating up and down. And on the right, you can see the charge of 4.29 e negative 9, where the magnitudes and directions of the electric force and gravitational are equal and in opposite directions. Moving on to the discussion, our final results showed us that the charge of 4.29 times 10 to the negative 9 coulombs matches both our experiment and code. Some similarities between the models is we simplified both of the tapes to a single particle to make it easier to find the exact charge, and some differences is how we found the charge, where in the experiment we did calculations while in the code we did trial and error. Some sources of error in the experiment could have been moving the lower tape while the upper tape was moving, so separation distance may not be accurate. Moving on to discussion questions, we found the magnitude of the charge to be approximately 4.29 times 10 to the negative 9 coulombs. And for any assumptions or approximations we made, we first were able to ignore a resistance, unmoving objects, since at the final state the tape was not moving. We were also able to use it as a point charge because otherwise there would be more forces in other directions on the tape, causing for changes. And we also assumed that the tape we made was the same amount of charge evenly spread, otherwise it would also cause for a different level of charge. In conclusion, we experimentally found the charge on two pieces of charged tape by balancing out the force of gravity and the electric force, as well as simulating it using code. Thank you for listening and have a good day.